Bob Lazar, frozen candle. Bob tells a story about how they lit a candle and when they pointed the reactor output on it, candle flame remained luminous and
that can actually alter the flow of time. I mean, that's the missing piece of pie.
Didn't they actually freeze a
candle?
A flame for
yeah,
you?
now that's when it was connected to the gravity amplifiers where they could focus it, and
They froze a candle?
A flame.
Yeah, they had a candle lit to set it up for you. Again, there's a large, in the craft itself, there are 3 long pipes. I'd say, well, I don't know about, what's that, 3-4 feet in diameter, maybe 5 feet long. Anyway, they dangle the 3 of them at the bottom of the craft. These produce gravitational waves, and they can focus them to a point or spread them apart.
Those are what you call the wave guides?
Yeah,
Okay.
yeah. They're part of the power source control mechanism and the wave, well, the waveguide is what I actually call the interlink between them, but that's the gravitational engine. They had one of those devices out along with the subsystem that connects it, so they can produce the power from the reactor, it runs the gravity amplifier, and they can focus and change the gravity beam that comes out of it. They took, speaking of Barry, took a candle, put it close to the mouth of it, lit it, a normal flickering candle flame, and then activated the reactor. The gravity wave came out as expected, and the candle flame remained luminous and stopped moving. And
Which defies physics.
yeah, because
The
look, if it's going to
photons-
freeze it, the photons should stop being emitted. If it's going to, change the characteristics. Look, how can the combustion continue to take place without the convection inside the flame? Because actually, the reason a flame is elongated is not really because of the heat, it's because of gravity. Because gravity pulls down and, convection moves flames upward. It's why in a zero gravity environment, flame is a ball. Obviously, there's nothing to pull things around. But anyway, if you negate the gravity around it, why is it still pointy? How can it still be making light? And why doesn't it move? Well, I mean, from what Barry said, it's not just gravity, but it's also time locked. You've distorted
the frame of time.
Yeah, they essentially froze a piece of time there. And what do you say? I mean, it's empirical evidence. You're looking at it. It's not
You can see it.
It doesn't make sense that you could see it. And look, the stuff I saw there was the most unbelievable, literally, because it defied what we knew as physics. And at least I thought it did. And maybe what we knew was a little incorrect and just needed viewing from a different angle.
Bob Lazar, frozen candle. Bob tells a story about how they lit a candle and when they pointed the reactor output on it, candle flame remained luminous and stopped moving. Bob described that the time slowed down at the area where they put the candle. The rate of slowing down, see chapter 1, is expressed in z+1, where z called redshift. Let's say it slowed down 101 times, could be any, should be measured at the site. So, if Bob stood right next to the candle, both for him and the candle, the time slowed down 101 times, so he would not notice anything weird about the candle flame, because time flow is the same for him and the candle. But when he stood outside, for 1 second passed inside the circle, 101 seconds greater than 1 minute passed for him. That is why candle flame does not flicker from his perspective. Watching the candle is like watching video at 100 times slower speed. But the most puzzling in this story, both for him and for myself. Look at chapter 12 to see why, was that he could see the candle. Our expectation was, it should be screened from us, turned out it is not true, or to be exact, not always true. By now you should be familiar with Snell's refraction from page 6. Sin r equals 1 plus z, sin b. Let's notice that for a large number z, 100 for example, if angle b is not close to 0, for example b greater than 1 degree, b of 0 degrees minus 90 degrees range, 1 plus z, sin b will become greater than 1, and that cannot be, because on other side it is sin r. Only light that is almost perpendicular to the time zone's border can cross it. What happens to the light that reaches the border at the angle far from a perpendicular? It bounces back equals reflects. And reflection law states that light bounces back symmetrically under the same angle. Here is proof. Proof. For the light inside circle, only very close to a radius, that is always perpendicular to the circle, light can get out, and the light that is reflected back, will continue reflecting again and again, because of the property of the circle, angle to the radius remains same. Now, regarding visibility of the candle, we will have several cases. Visible. We can see the candle on the screen where it is marked in orange. In this position of the candle and the observer candle flame is visible on the screen, and its image is a bit enlarged and a bit shifted, mirrored. There are positions at which the candle is still visible, but its image is flipped and is seen far away from the actual position. Position. Glowing screen. If the center of the screen is inside the candle flame, we won't see the candle, but we'll see a glowing sphere. Luminosity will be low compared to the candle luminosity, because light is dissipated over the screen. The orange arc is huge. Huge. Invisible. And there are two areas of invisibility in white. White, but in still can be seen at a different angle, from another position. Wavelength and visibility. Another aspect of visibility is wavelength. Our eye can see only a certain range of wavelengths, usually at wavelengths from 380 to 700 nanometers. Visible light, when redshifted or blueshifted, can become invisible. If 380 to 700 nanometers wavelength doubles, then 760 plus nm light is invisible to a naked eye, and if it is blueshifted to a half of wavelength 350 nm, then it is invisible too. And on the contrary, some light spectrum which was invisible can become visible after redshift or blueshift. In the story with the candle, we shall wonder why the candle light is still visible after strong redshift, caused by time dilation. Candle light is produced from chemical reaction between candle wax molecules and the oxygen, from electron interactions of C and H atoms of the wax and O atoms from the air. Atomic time is autonomous, independent from the time of the environment, space. So, change to the wavelength of the light emitted by the candle flame occurs twice, from point A to point B, and from point B to point C. From point A to point B wavelength decreases, Z plus 1, times, and from point B to point C it increases, Z plus 1, times. So, to the eye, point D, it arrives unchanged at a visible range for the eye, in a usual spectrum at which candles glow. I simplified the explanation. Actually, time in the candle A could be different from normal time at C, and normal time at C could be different from time in the ID, but point is, adding layer B between A and C does not change A to C wavelength ratio, because it is divided by Z plus 1 between A and B, and then it is multiplied by Z plus 1 between B and C. C intermediate redshifts cancel out. Wavelength B, wavelength A, wavelength C, wavelength B. Wavelength D, wavelength C, equals wavelength D, wavelength A, and wavelength 1/second, is in reverse proportion to time. Faster time corresponds to shorter second and longer wave. Wavelength D, wavelength equals second A, second D. Thus, visibility depends on time speed at the beginning and at the end. For some other cases, when light is bounced/reflected, beginning is not at the reflection point, but before. Read free ebook Beyond Cutting Edge with Bob Lazar in PDF, Amazon, Google.